All right, so I will get started. Did you guys have any, where's the sheet I had back? I picked it up. Oh, I don't remember that. Oh, man. I already picked it up. Okay, well, good. And I was just explaining before I started hit the record button that I passed out a 2-page summary of the theory we covered last time. So, of course, this is also in the textbook that you guys don't read, but it's also in the textbook. Part of it's in like chapter 4, part of it's in chapter 7. So I think it's nice to have it all together. I also intend to add to this, like a half dozen examples or something, just to try to draw together like the examples we did last time. Anyway, do you guys have any particular questions about the homework or anything? No? All right, so let's look at another example. So let me just remind you, I kind of downplay this, but let me show you an example that's so hideous that we'll use it. Oops. So minus b plus or minus the square root of b squared minus 4ac divided by 2a. All right. So here's an example where we might want to actually use that. Something like this. 0.375x squared plus 0.13x plus, I don't know, let's see here, 2.7 equals to 0, right? Now, where do you come across this kind of equation? Well, like in a science class, right? There are science classes where you don't have, like everything we do in here, it always works out to what? Like 1 or 2, all these whole numbers, right? This is not how the world looks, right? When you actually solve real applied problems, you tend to get uglier coefficients, right? And for those kind of problems where you actually have ugly coefficients, those kind of problems, factoring is not a good idea. Completing the square is a monstrosity. Really, the quadratic formula is the way to go for this kind of example. So really have no recourse but to do that. So here it goes. So we do minus 0.13 plus or minus the square root of 0.13 squared minus 4 times 0.1, well, excuse me, I can't do 375, right? A is 375 times 2.7, right? And we divide by, what do we divide by? 2 times 0.375. Now it looks to me like we're going to have a complex solution unless I change something. Do you guys want to have a complex solution or you want to have a real solution? What's your preference? Votes for keeping it complex. Votes for making it real. Votes for I don't care. Real? Okay, real. So to make this real, I need to somehow make this term positive. So, and this freedom is not given to you on tests. Like, you can't just change problems, but I can at this point. So I'm gonna make that a minus. If I make that a minus, that puts a minus in here, right? And then that's positive. The discriminant will be positive. We'll have distinct real roots. Okay? Now, when I face a calculation like this, if all I've got is my calculator, I do not try to do it all at once. That is not a good idea. What you want to do is break it into like little pieces, right? So what is this number inside? Like I would first figure that out. What's the discriminant? So get out my handy dandy calculator. Now I will say, all right, so here we go. 0.13 squared minus minus gives me a plus, so plus 4 times 0.375 times 2.7. That gives me 4.0669. Now I will say there's a danger in doing it step by step. If you throw away digits, that can accumulate error in your calculation, right? So in the intermediate steps of your calculation, you should keep at least one more digit than whatever the significant figures is in your problem, all right? So, and what's the denominator's what? What's 2 times 3.75? We can do that. That's 0.75. All right. So I get, what's the square root of, oh, wrong one. What's the square root of 4.0669? Well, it is 2.0166, I'll just say 666. It goes on from there, but. All right, so, okay, let's figure those out. That minus 0.13 gives me 1.8, let's say 1.88. So I'll just keep 4 digits here, 887 divided by 0.75, or that's from the minus. From the plus, I get 2.1466 divided by 0.75, right? So, okay, to complete the calculation then, divide that by 0.75. I get 2.86 for the plus one. Well, 2.862, all right? And for the negative in the formula, 1.887 divided by 0.75. And that gives me 2.516. So there you go. Like, this is the kind of example where I would use the quadratic formula for, right? So if I put a problem on the test that has significantly ugly numbers, what should you do? Use the quadratic formula, right? Now, depending on what kind of calculator you use, it actually may have a built-in quadratic solver, right? So for example, this relatively low-tech, I mean, I've had this thing like 10 years, right? And they pretty much sell the same thing at Walmart at the moment, I think. It's like 15 bucks or whatever. But if you fish around in here, it's got if you got like shift, solve equals, where's that thing? It takes me a while to find it, but it's in here. It actually has a place where I can, I think I have to put it into the equation mode, so I have to go to mode, equation. Once I'm in equation mode, it pops up a list of problems. And like if you look at number 3 on my calculator, let's see if, well, this probably won't work, but it's going to work. I don't know, maybe. If you look at number 3, you can see it's a quadratic equation. Sorry, you guys. I could pass around my calculator, but it'd take forever. So I go to 3, and then once I get to 3, it gives me this template. I guess you have to watch the video later. This template here, A, B, see if I can get it to focus. A, B, C. My apologies, I can't really see either. A, B, and C. So what do? You put in the coefficients into the A, B, and C, which here are 0.375. I hit enter. 0.13. I hit enter. And minus 2.7. I hit enter. And then I hit enter again. And the calculator thinks for a second. And it tells me that x1 is 2.51555, blah, blah, blah. And hit enter again, if I can find it. Where's enter? I don't know, I think it's the AC button. No, that was not what I wanted. It's the equals button. Hit the equals button. AC is back. So I hit the equals button again, and here's x2 minus 2 point, minus, oh man. Uh-oh. 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 Minus 2.8622. You guys should have called me on this like 2 minutes ago, right? You're gonna make me do all the work up here? Where's my error? Can you guys tell me? Error. I do have an error. Divided by, yeah, so how about this one? I do, so in the, are these both an error actually? Let me think about this again. So I have minus 0.13 plus 2.0, blah, 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 1.88, that's reasonable. But when I have minus and I have minus, what should I have over here? I should have a negative, right? So one of these answers is negative, is the point. So if I follow, I got lost in the numbers here. So there's a minus here, which puts a minus here as well. And this is, of course, actually the plus solution, and this is the minus solution. My bad. Sorry, guys. All right, let's work another example. This one should be a little bit easier. Example 2. Let's solve x squared plus 17x minus 18 equals to 0. So I'm going to give you guys a minute. You should be able to solve this, all right? Try to solve it yourself. I'll give you a little bit of time. No, I sure don't. The copier jammed. But I will scan it and put it in the course content. If you don't want to wait, you can take a picture of it.
Okay.
Yeah, sorry about that.
No, that's fine.
Stupid copier.
I should have got here on time.
Well, you might just, depending on, yeah, you would have got it. I was from the front to the back. And what's your name again? Joanna. Aha, I'll mark you. You've been marked. Uh-huh. Anybody tell me the answer to the, what'd you get?
A.
This one?
No, I was thinking I see that.
Oh, sorry. That's just a summary of the things we went over last time. I'll try to keep emphasizing them in the examples today, okay? But, so, anybody? I would recommend not using the quadratic formula for this one, right? What you should do is something like this, right? X squared plus 17x. And I really don't want to complete the square here either because it's ugly. But I think we can factor this one. What do you guys got? I'll put the x's in for you. Plus 18 minus 1. I knew somebody in here would have figured it out. Let's see, plus 18 minus 1. I bet a bunch of you have this, but don't want to admit to it. Oh, so then what? This is equal to 0. What does it tell you the solutions are? So x equals to, I heard minus 18 and positive 1. Very good. Now, let's see here. Piggybacking off of this, can you tell me anything about the graph? If we're to think about, so let's continue this story up here. All right, so if I'm going to draw a graph of this, can you tell me some things on the graph? Like where does it have x-intercepts? Yeah, minus 18, right? Like maybe over here, and 1, right? X-intercepts. How about the y-intercept? Where's the y-intercept on this thing? What's the y-intercept on y equals to x squared plus 17x minus 18? What is the y-intercept here? Negative 18. Very good. So that's kind of cool. That's just the same. That's interesting. So it's down here. All right. I'm starting to regret the scale which I chose. Where's the vertex? Negative 8.5. Vertex. at x equal to negative 8.5. Very good. What's the y on the vertex? Yes. So you could plug negative 8.5 into the formula and see what it works out to, right? Or you could use the formula on the sheet if you wanted to, right? What does it tell us? The vertex is where? Where is that thing here? It's on the second page. We're told that it's at c minus b squared divided by 4a, right? So for this problem, that's minus 18. What's b? B is 17. 17 squared, divided by 4 times 1. So whatever that works out to. So that formula is a little bit easier than just plugging the number into the quadratic, but not significantly so. So like, I don't know, if I'm going to find the vertex as a student, I'm probably just going to take the x-coordinate, which is easy to find. The way he found that was what? What's this minus 8.5? Where's that coming from? There's two ways to think about it, right? It's midpoint of roots, midpoint of x-intercepts, right? If you got them. Or it's also, what is it, minus b over 2a, right? So that's minus 17 divided by 2, which is, by the way, minus 8.5. So that's where that minus 8.5 came from, right? Actually, who told me minus 8.5? Which way did you do it? The first way? Okay. Yeah, I like that way. So what's the value for the y of the vertex? Minus 18 minus 17 squared divided by 4. That gives me minus 361 over 4, which I don't particularly care for. Oh my goodness, minus 90.25. Yes, indeed, I do regret. So minus 90.25 is hard for me to picture. Yeah, so here's the axis of symmetry for the parabola. And I don't know if I'm going to get to 90. This is 18, so 90 is about, it's kind of sort of 5 copies of 18. Is that right? 5 times 18 is 90? Oh, it's exactly 5 copies, so this happens to be 18. So 1, 2, 3, 4. Ah, I got it. It actually fit. That was close. And then once you've got 3 points, you've got the axis of symmetry, you can pretty well graph the parabola. Well, you can try. I tried. That should be more, this is not actually happening in the parabola, right? That's just my inability to graph 3-foot graphs like at that level. So anyway, something like that. So you find the x-intercepts, you find the y-intercept, you find the vertex, you pretty much know where the parabola fits in the graph, right? And we can get all those things. Let me give you another example. All right, let's suppose that is at minus 1. This is at 3. And the vertex is at, oh, I don't know, let's say 1 comma minus 2. Right? And then here's the question. This is y equals to ax squared plus bx plus c, right? So the question is this. Find a, b, and c. So now I'm asking a backwards question. Here's the graph, find the parabola, find the formula, which this is the graph of. Right? How do you do this kind of problem? Remember our factor theorem? What does the factor theorem say? Factor theorem says f of c is equal to 0 means that the product, that means the x minus c is factor of f of x, right? So like you look at this graph, what can you read from that? You can read f of what? F of minus 1 equals to 0, right? And you can also read f of 3 equals to 0 from the graph. Do you guys see that? From this point and that point? Okay. So what does that tell me? That tells me I've got an x plus 1 factor, and I've got a x minus 3 factor, right? You put that together, you've got that ax squared plus bx plus c has to be equal to a times x plus 1 times x minus 3. You got to leave the a out front because we can't assume it's 1. It may be something else, we don't know. Right? If you just put 1 there, you'd be stuck with a very specific parabola which may or may not have that as a vertex. Right? Is that the only parabola with x-intercepts minus 1 and 3? It's not, right? Like, I'll draw it over here, not to clutter my picture, but if you think about minus 1 and 3, and you start thinking about what parabolas have those as x-intercepts, well, there are many parabolas which have 1 and 3 as x-intercepts. There's an infinite family of them, actually. All of these are parabolas which share minus 1 and 3 as x-intercepts, right? So x-intercepts alone are not enough to pin down the parabola. You have to know something else. We know a vertex, though, so you guys tell me what to do with it. A lot of different paths forward from here. But somehow or another, we have to use this data that we're given, that 1 minus 2 is the vertex. How should we use that? What does that mean? If 1 minus 2 is a point on the graph, what does that tell you? F of 1 is equal to what? What's this tell us? This tells us f of 1, right, is equal to minus 2, right? But this right here, guys, is f of x, right? So we could calculate f of 1 from there. So f of 1, it's equal to minus 2, but it's also equal to a times 1 plus 1 times 1 minus 3, right? Aha, now we've got it, right? We can solve that for a, and that will give us the answer. Well, we still have a little bit more work to do, but let's solve for a. What do we got? We got 2. We got minus 2. So 2 times minus 2, minus 4. We've got minus 4a. Divide both sides by 4, what you got? A equals to 1/2, right? Because 2 minus, well, I'll write it out. I'll do the steps here. Sorry, minus 2 over minus 4, but that's equal to 1/2. Right, so a is equal to 1/2. Now, what was the question? The question was to find a, b, and c. We've done 1/3 of it. We know a. We don't know b and c yet. How do we find b and c? So we've got f of x. You said plug it in. What did you say? I didn't quite hear. Plug it in. Yeah, oh yeah, plug the half in. Totally agree with that. Then what? Now we go back to day 1 with polynomials, right? Remember, we talked about coefficients, talked about standard form, all that. We're back there now. We need to multiply this out, right? FOIL it out, then we should see it, right? So I'll keep the half out front just to start with, and that's going to be x squared minus 3x plus x minus 3. So combined like terms, I've got 1/2 x squared. Minus 3 plus 1 is minus 2, so minus 2 over 2 x minus 3/2. In other words, we got 1/2 x squared minus x minus 3/2. So what do we find? We've got a equals to 1/2, right? B equals to what? C equals to what? How do you read the coefficients off a polynomial? What do you do? It's not a tricky question. You just look at it, right? By inspection. So what's b? If I put minus x, b is, well, 1 is negative 1, right? B is negative 1. And what's c? Well, c is minus 3/2, right? So there you go. That's the answer. So I know we haven't done a problem quite like this before. It's a backwards problem, but there it is. You guys have any questions? Move. You're like, I like example 2. We should do more examples like example 2. Maybe, yeah. All right, so here's an example. I think it would be healthy for you guys to try to work out. It's a little bit difficult, but you should try. So I'm going to give you a couple minutes to try this one. Example 4. I want you to try to solve 3x squared plus 10x minus 6 equals to 0. All right? And I'll tell you right now, you want to use completing the square. All right? Try it out. You can either go with the factoring idea that I gave that's on the sheet that you looked at, or you could go with the isolate the square, take the square root of both sides, plus or minus thing we talked about last time. Either's cool. So I'll give you guys a little bit of time here to try to work on that, and then we'll come back and see where you guys got to in about a minute. All right? In the meantime, I'm going to try to get something out over here. Are you guys hot? Or is that just me? Hey. So what'd you guys get? You're like, a mess? Let's see here if I can help out here. So I'll start with factoring the 3 out. All right, so 3x squared plus 10x minus 6. This is 3 times x squared plus 10 thirds x, right? Excuse me, yeah, 10 thirds x. What's minus 2, right? So that's the first thing I do. Now we're setting this equal to 0, right? So if we want, we can divide by 3, right? And we can just look at, so that's the same as the equation x squared plus 10 thirds x minus 2 equal to 0, right? Excuse me. So now we'll complete the square. So to do that, we take half of the middle. What's half of 10 thirds? It is 10/6, right? Which you could also write as what? 5/3, right? 10/6 is 5/3. So we have x plus 5/3 squared, and then we have to subtract the square of whatever we find here. So we have to subtract 25 over 9 in this case, right? Because 5/3 cubed, squared rather, it's cubed, listen to me, is 25 over 9, right? And then we still have the minus 2. So I think the easy way to go is to isolate the square, right? So I'm going to isolate the square. So we've got 25 over 9 plus 2, right? So that's 25 plus 18 over 9. Didn't they just mow like yesterday? I'm going to give him the evil eye. He's not going to see me, though. Nah.
My allergies is messed up by that.
Your allergy is a...
Like, I can't be outside with them.
Oh.
It's so bad, my legs get itchy.
Ooh, yeah. That happens for my son. Whenever he mows our yard, he gets all...
I was outside one time with my parents. They were going to the mall.
Mm-hmm. I have that problem, even like my neighbor mows the yard, because it just kicks up so much dust, you know? Anyway, so 40, I think 25 plus 18 is 43. The reason there's an 18 there is we need to make a common denominator, right? So 2 is 18/9. Does that make sense? I hope. And then what do? We take the square root of both sides. Remember, we have to allow for plus or minus. So this gives us x plus 5/3 equals to plus or minus the square root of 43 over 9. Well, the good thing is we can rewrite that as plus or minus the square root of 43 divided by the square root of 9. What's the square root of 9? I heard a 3. So then this gives us x is equal to minus 5/3 plus or minus the square root of 43 over 3. There you go. Now, if you're careful, what's another way you could do this? You could use the quadratic formula, right? So, there's an example. So I was just glancing through your homework, and I saw a problem which is of a slightly different format than we've done. So let me do one like that. It's really simple, really simple. What if you were asked to solve something like, say you had minus 2x plus 3 squared equals to 18. Solve this. How would you do it? So in order to use the square root trick, all right, to solve an equation, we have to actually have a square. So the first thing I would do here is multiply both sides by minus 1. All right, so that gives me 2x plus 3 squared equals to minus 18. All right. And now I can use the square root. Take the square root of both sides. Remember, plus minus. 2x plus 3 is equal to plus or minus the square root of minus 18. Now, the square root of minus 18, well, that's a complex. It's an imaginary number, right? So this can actually be written as plus or minus I times the square root of 18. All right? And I guess we could simplify that further. Can you guys tell me how to simplify the square root of 18? What is square root of 18 is 2 times 3 times 3, right? 2 times 3 squared. So that's the square root of 2 times the square root well, I could just write. Sorry, guys. I'll make up my mind here. So the square root of 18 is the square root of 2 times 9, which is the square root of 2 times the square root of 9, which is the square root of 2 times 3. But I like to write it 3 root 2 because it just looks better. So in short, this is plus or minus 2i times the square root of 3. Now, let's solve for x. Well, we've got 2x is equal to minus 3 plus or minus 2 times I times the square root of 3. So admittedly, this looks different than the problems we've worked before, but the steps, the technology we're using to solve it, it's all the same, right? Isolate a square, use a square root plus or minus theorem, and then at the end of it all, isolate x, right? But this time we've got the extra step that we need to do what? Divide by 2, right? We got to divide by 2 to isolate x. So we do that, and we get x is equal to minus 3 over 2 plus or minus 2i times the square root of 3 over 2, which of course gives us x is minus 3 halves plus or minus I root 3. How could I have changed this problem to make it have a real answer? What would I have to do to make it come out to a real number instead of an imaginary number as my answer? It's a pretty simple modification we can make to this problem. So like if instead of having minus 2x plus 3 squared equals 18, if I just put a minus 18 there, right? Then the minuses would have canceled and pretty much the same steps, right? Take a square root of both sides, we get plus or minus the square root of 18, right? Which is, by the way, plus or minus 2 times the square root of 3. And then that gives you 2x equals to minus 3 plus or minus 2 root 3. Then divide by 2, and we get this. So they don't have to be imaginary, these problems, is my point. All right. So I mentioned to you guys that I didn't learn completing the square until I was in differential equations, right? And you might wonder, how did I get away with that? Like, how did I factor quadratic equations or factor quadratics if I didn't know how to complete the square, right? Well, I had a way around it, all right? Let me describe to you my workaround. And so if you like it, you can use this instead of completing the square, but it does come at a cost of considerable calculation. So just let's make up an example here. Something like, I don't know, 2x squared plus 13x minus 30. All right. So equals to 0. And let's see instructions. Solve the equation and factor 2x squared plus 13x minus 30. All right. So what I would do, because I had calculators which would easily solve the quadratic equation, I would just plug it into my calculator and find the solution. So I'll just write it down here. X is equal to, minus b plus or minus the square root of b squared minus 4ac divided by 2a. So here, a equals what? Yeah, a equals 2, b equals 13, c equals minus 30. So it's a little bit unpleasant, but here it is, minus 13 plus or minus the square root of 169 minus 4 times 2 times minus 30. All right, divided by 2 times 2, which is 4. So that gives us minus 13 plus or minus the square root of something unpleasant. 8 times 30 is 240. 240 plus 169 is 340. Plus 69 is 409. 409. So, hey, behold, we have solved the problem in the sense that did we solve the equation? Yes, we did. Those are the solutions to the equation. Right? Put a box around it. Yay. Solve the equation. Check. Now how do you factor? You can factor by using the factor theorem. The factor theorem tells me what? Says, what does it say? It says, since f of minus 13 plus the square root of 409 divided by 4 is equal to 0. What's that say? That says that x minus 13 plus square root of 409 divided by 4 is a factor of f of x. Right? And because I don't love writing, I'm going to go ahead and put a minus in here in a different color, right? Because I can do that. So both cases, the plus and the minus give us a factor. Right? And we know that f of x looks like what? F of x looks like some leading coefficient times x minus r1 times x minus r2, right? Well, we know what r1 and r2 are. They're these things we just found from the quadratic formula. Those are the solutions. So what's a? Up here, right? A is 2. So the factoring of this is just twice, x minus, well, I could say x plus, I'll just stick with the format I had. X minus, it's kind of tacky, but minus 13 plus the square root of 409. This could be simplified. I'm just keeping it like it is for maximum transparency. We all like transparency, right? You guys aren't government officials. So square root of 409 over 4. I mean, it's not just the government which doesn't like being transparent. It's like every large corporation. Anything that has a marketing department, there's not going to be transparency. It's a general rule. Just saying. Anyway, that will not be on the test. But there you go, factored. That's probably the best way to factor this. I mean, you could use completing the square. It'd be about the same difficulty. All right. But that is how I used to factor things that I couldn't just like the next example. Let's do a bunch of easy examples here. I mean, easier examples. So each one of these you can factor and solve, okay? So you guys try to work these out. Let's see here. I'll make this one a little bit harder. There you go. I'll give you guys about a minute to chew on these, and then we'll look at the answers. Question, do you prefer this format where I leave a minute for you to work it out before I tell you the answer? Is that beneficial to you? I haven't been doing that up to this point. I've just been kind of going forward. I think it's a good thing to do once we've sort of talked about how everything works, right? When we get to this kind of more of a review day, it's good for you guys to spend some time trying to work it out yourself. I shut up. Oh. Oh. I think it's been a minute. Let's go through here. How about the first one? You guys tell me what to do. How about this is x. So what we put here, 25 we can get from 5 times 5. Hey, that works, right? Put 5 and 5 here. X plus 5 and x plus 5. Multiply it out, we get what's right there. So in this case, we've got x plus 5 squared, right? So what's the solution? There's just one, right? X equals minus 5. And you could say it's twice, right? I mean, it's a repeated solution. I mean, that's there's really just one solution, though, truthfully, right? How about the next one? It's the same. Yeah, this is x minus 3 squared. So the solution is x equal to 3. How about the next one? I heard a 2 and a 4. Very good. Plus 2 plus 4 equals 0. And we should always check it, multiply it out, right? 2x plus 4x gives me the 6x. 2 times 4 gives me 8. X times x gives me x squared. We're good. So that tells me x equals to what and what? Sorry, I was writing on the board. I couldn't hear. -2 and -4. Hey, I think some people are going to pass the next test. So, hooray. Not just survive, I believe thrive. This is what I'm hoping for. All right, so 2 times what? 2 times what? Let me say this is 2 times x squared plus 3x plus 2. Like, that's the first thing you should do here is factor that pesky 2 out and trade this for the much simpler problem of what? 2 times, how's this factor? Plus 1 plus 2, right. And so that equals to 0 tells me what are the solutions. X equals to either minus 1 or x equal to minus 2, right? So minus 1 and minus 2, I should say and. X equal minus 2 are my solutions. All right. So I thought I assigned you guys some word problems. We should do a few of those, right? Yeah. Here's one. Let me kill some of the lights. Well, all of the lights, I guess. I don't have, it's an all or nothing kind of deal in here, isn't it? Make this a little bit bigger so we can see what's going on. We'll try to see what's going on. I don't know. Well, here, I'll just zoom in on the question for a second. Sorry to the people at home, but can't have our cake and eat it too here. This room just doesn't allow it. All right, so I'm going to turn the lights back on. Well, man, I need to get like a lamp in here or something. I don't know. Can I erase these? Okay. What? No? Oh, just stretching your neck. Or you're from another culture where like this means yes. Okay. I like that. That's a good answer. All right, so we have what here? The base of a triangular sail is 8 meters shorter than its height. Right, so we've got, this is x, this is the height, right? And down here, what do we sell? The base is 8 meters shorter than its height. What does that mean? That means that the base is x minus 8, right? I'm adding that. That's not in the problem, right? This x minus 8, that's a thought that comes from reading the thing and applying what x means to the statement. X minus 8. Now what? We're supposed to find the base and height of the sail. Oh, the area is 24 meters squared. Okay. So what's the area? So guys, the area is equal to 1/2 base times height, right? So that is what? 24 is equal to 1/2. The base is x minus 8. The height is x. This is why this is in chapter 7, because after you sort through the words in the word problem, you have a quadratic equation. Can we solve this? Let me ask a slightly different question. Is there any quadratic equation we cannot solve? The answer is no, if we have studied. So hopefully the answer is no. But this one we've got to work out. Okay, so this is, so sometimes students, I've seen this a lot. What students will do if they see a problem like this, there's a great temptation to maybe move 2 to the other side. You got 48 is equal to x minus 8 times x. And then you guys will go, oh, well, that must mean that we're looking for the product of two numbers who's equal to 48. And then you just like find something that works and force that to be the answer. You can't do that. Like, it's perilous at best. I mean, you might get lucky and guess it. If I stare at this for a couple minutes, I can guess it, but let's not do that. So what we got is x squared minus 8x. Let's do it properly. So we've got x squared minus 8x minus 48 equals to 0. I believe in book problems being easy, so this should factor. All right. How do we get 48? How about 6 times 8? Oh, that won't help. 4 times 12? 4 times 12. 4 and 12 are interesting. They're 8 apart. How about that? So maybe minus 4 and a plus 12 would do nicely. Did that do nicely? Check your answer. We get minus 4 plus 12. Oh, that's not good at all. That gives us some positiveness. So we do what? Positive 4 and negative 12. That's the way to go. And that tells me what? X is equal to minus 4 or x equals to 12. Ah, this is wonderful. So what can you say me? What can you say to me about x equal to minus 4? What kind of solution is this? X is what? X is a length. Can it be negative? No, that answer is physically unreasonable, right? It's what's called an extraneous solution. So I often tell students that if I was to be a rapper, that my name would be Extraneous G. And my tagline would be, I'm not even in the solution set. And that's how I would roll. But I'm not a rapper, so go figure. I can't even like sing and clap. Like you can either get singing or clapping. Like I can't do both. Anyway, so x equal to 12 is the answer. That is part of the answer. What's the whole answer? We need to find the base and the height. So the height is 12. What's the base? 12 minus 8, right? So 4 meters is the base. Make sense? Let us look at another one of these. That one's the same problem, essentially. Here, we'll look at this one. This one's a little bit different. A student opens a mathematics book to 2 facing pages. The product of the page numbers is 1482. Find the page numbers. So you got a book, 2 facing pages, so like this page and that page. Let's say this is page 1. So if we call x this page number, what's the page number of the next one over? No, they're adjacent. So if this is like page 10, this is page 11, right? So we do what? X plus 1, right? So again, we have the product of 2 facing pages is 1482. We're supposed to find the page numbers. This is a more convenient problem to put on a test because it doesn't require me to make a diagram of a sale. Just saying. Although I was chastised for the small number of problems on your test. Apparently it's expected to give you guys like 25. But I don't know. In my defense, I feel like if you get 15 wrong, I can tell what you're going to do with 15 problems. I don't really need 25. I don't know. The next test will be longer. So x times x plus 1 is equal to what? Apparently 1482, right? That is a quadratic equation. Let's solve it. X squared plus x minus 1482 equal to 0. Well, how does 1482 factor? I mean, you got choices here. We could complete the square. We could try to figure out how does 1482 factor as a number. What do you want to do? What is it? Factor? Okay. So if we're going to go down that path, the first thing I do is divide by 2. And that gives me what, 741? So 1482 is 2 times 741. Does 741 factor? Well, the sum of the digits is 12. That means 3 factors that, I believe. So I think you can factor a 3 out of that. 247. So this is 2 times 3 times 247. 247 doesn't ring a bell with me. Does that factor? What, 13 times 18? Hey, very nice. How'd you do that? Calculator? Your calculator factors numbers? Hey, that's not fair. Mine won't. I mean, I can do that in Wolfram Alpha, like online easily, of course, but okay, so goodness. We need 2 numbers where one is bigger, like one is bigger than the other by 1 and the other one's just behind it, right? 3 times 13 is 38. It's 39 rather. See that? And 2 times 19 is 38. So it's going to be those 2. So we should do x plus 39 times x minus 38. I'm just going to say this. This is not a valid method if this problem comes up on the test. You should definitely try to either use the quadratic